Hi, welcome to my video on the extra word problem on finding the equation of a tangent to a curve. Again, this is an extra problem. And this is a good problem to end off this unit before we do the review. Find the equation of a tangent to y equals x squared minus 3 at x equals negative 2. The equation of the tangent is, because it's a tangent, then we're going to have to look at the slope of the tangent. And the slope of the tangent is the slope of the curve at x equals 2. Notice that y equals x squared minus 3 is a parabola, because the parabola is y equals ax squared plus bx plus c. So this is a parabola, and we'll look at more values of the parabola now in a minute, more features. I just want to get back to the slope of the tangent is the slope of the curve. So that's the slope of the parabola at x equals negative 2, which is the instantaneous rate of change at x equals negative 2. So we got to find the instantaneous rate of change, which is the slope of the tangent at x equals negative 2. So let's look at x equals negative 2. So y equals x squared minus 3. Y equals negative 2 squared minus 3. 4 minus 3 is 1. So this is at the point, which is negative 2, 1 on the parabola. So this is the point on the parabola where we're going to find the tangent. But we also, to do the instantaneous rate of change at this point in the math, we have to look at finding the instantaneous rate of change. So I'm going to add on 0.001. So that gives me negative 1.999. So we'll sub that into the x, negative 1.999 squared minus 3. And if you use your calculator and work that out, you get a 0.996001. So that point is negative 1.999, giving you a y value of 0.996001. So let's find the slope. The instantaneous rate of change is the slope. So the slope, as I do it, is y2, 0.996001, minus y1, which is 1. x2 is a negative 1.999 minus x1, which is negative 2. Notice that this is a double negative, so we make it a positive. So when you fill this in your calculator and work it out, it comes out to negative 3.999, which is approximately a negative 4. So the slope of the tangent is the instantaneous rate of change at negative 2. The slope of the tangent is negative 4. But the equation of the tangent is y equals mx plus b. And the slope of the tangent is negative 4. So m is the slope, so we fill in the negative 4. Now, this tangent is occurring at x is negative 2. So it's occurring at the point negative 2, 1. So that's the point on the curve, negative 2, 1 that is occurring at. This is the x and the y. So if you take the y and sub in the equation, sub the x in the equation as negative 2, we'll find b, which is the y-intercept. So that's 1 equals 8 plus b. So b is 1 minus 8. So b is negative 7. So the equation of the tangent to this parabola is y equals, and slope is negative 4. The y-intercept is negative 7. So that's the equation of this tangent at negative 2. Now, since it's a parabola, let's look at it a little bit more just to see. And we have a parabola that's y equals x squared minus 3. The vertex of this parabola is, notice we have no value of x. So if you did, there's no b is 0. So negative b over 2a, the x value of the vertex is 0 because b is 0. So if you put a 0 in here, you get a negative 3. So the vertex is 0, negative 3. So let's put it here just to do this. So let's say this is negative 5. So there's 0, negative 3 is the vertex. So if you take other values and it's going up, it's symmetrical. So let's put some more values in here just to show you. Let's take x to be 1. If you put 1 in here, you get 1 squared is 1, you get a negative 2. So 1 gives you negative 2. Since this is the vertex, this is the axis of symmetry, so that means that a negative 1 should give you a negative 2. If we put 2 in here, a 2 gives you 4. 4 minus 3 is 1. So it gives you a 1. That means if 2 gives you a 1, negative 2 should give you a negative 1. Or sorry, negative 2 should give you a 1. Perfect. Let's put a negative 2 in here. Negative 2 squared is 4. 4 minus 3 is 1. Perfect. And there's the point there. So this is the parabola that we're looking at. Now I wanted to show this. So there it is. But we're looking at the tangent at negative 2, 1. There's the equation. So the y-intercept is, there's a 5, 6, 7. The y-intercept is negative 7. So there's negative 5, negative 6, negative 7. There's the y-intercept. And the slope is a minus 4 over 1. So that means at this point right here, if I took this point and went down to here, I should pass through this y-intercept. So negative 4 over 1 is down 4. 1, 2, 3, 4, right 1. And if I go down 4 again, 1, 2, 3, 4, right 1. So the tangent to the curve is at this, on this point right here. This is the point, negative 2, 1. So the tangent is, and it's, there it is. So this is an approximation. Again, it's an approximation, but I wanted to show it to you. The instantaneous rate of change is slope of the tangent, and of all the math we just did, it wanted to look at the equation of the tangent. This is what it was all about, getting to this calculus part, finding this tangent at this point. And so I'm trying to illustrate it here. Hopefully you can understand what I'm trying to do to find the equation. All the work we did in this unit was to get to this instantaneous rate of change, which is what we're going to do when we go to the calculus. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.